I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 17th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see remnants of what was strong storm number 10 fading out in the northeastern Gulf of Alaska. Remnants of yet another gale that moved off of Japan, fading northwest of Hawaii, and another small gale off the Kuril Islands. The storm pattern is not over quite yet. As usual, we'll start off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when gales form, help direct their track. We're looking for a trough, just like this right here, a dip in the jet stream aloft. And what that helps do is create a counterclockwise flow aloft and down at the surface. And that is the hallmark of low pressure. And if low pressure is deep enough, it generates winds. If the winds are strong enough, they get traction on the ocean's surface, generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a pretty healthy and consolidated jet stream flow, as has been the case for a month now, with winds 200 knots pushing off Japan, falling into a pretty broad trough here over the, we'll say, the Dateline or the western Gulf of Alaska. Then a bit of a ridge here, and that it works the opposite of a trough. It creates high pressure. And if you were in California today, you know it was a beautiful, warm day, not a cloud in the sky, about as nice as it could possibly get for this time of year. And that's pretty good for surf conditions as well. All right, so let's put this into motion, see what's going to happen. As we move into Monday, now notice the trough very quickly gets pinched off, and that's good. I mean, that's not good in that it doesn't really help promote circulation or support gale development. Winds still hold off Japan, so whatever was happening here is going to fade out. Notice the ridge starts amplifying and pushing way to the north, and then also notice the jet starts falling down the U.S. West Coast. And this is often what happens when you get a what they call a backdoor front. The front, instead of coming off the ocean, falls down from the north, brings a lot of cold air with it, and if it has sufficient moisture, makes very light and dry snow, which is great for, of course, boarding or skiing, but doesn't do a whole lot to help raise the water table, or it doesn't hold a lot of water content. And especially if you have very warm conditions, and then all of a sudden it gets cold, you have sheet ice on the, whatever snow's there basically turns to sheet ice, and then you start dumping dust on top of it. That dust, if it has sufficient depth, will be very easily avalanched or slide off. So kind of a interesting situation here as we move into the next week. All right, let's put this into motion. So anyway, as we get into Tuesday, jet holds pretty good. Trough tries to dig out here over the western Gulf, but notice the jet's really split over the Gulf. One branch, the northern branch, pushes up here into Canada, the other falling hard south over Hawaii, and that only supports more high pressure development there. As we get into Wednesday, new trough starts building off the Kuril Islands, possibly supporting gale development. The split jet stream flow continues over the east. Notice wind speeds start fading a little bit in the jet here as we get into Thursday. Still a pretty good trough holding here over the, we'll call it the North Dateline region. But notice the magnitude of the split here. The jet's just pushing as hard north as it can go and as hard south as it can go. But a little backdoor front there looks to be pushing, is forecast as we get into Friday night to push down over North California. Continuing into Saturday, the split almost looks like it's going backwards now to the Dateline. And then as we get into Sunday, things just not looking particularly good. What was basically an insane pattern of the jet just being consolidated, raging from Japan the whole way across the Pacific and then ridging north right off the U.S. West Coast. now looks like what you would typically expect during a normal La Nina year. No energy transport into the jet. Whatever you get is in the west. It splits heavily, and, so this looks like what we thought the year was going to be all year. We got lucky. We got about a 1 month break, but looking at the jet stream flow right now, it doesn't look like that's going to come back anytime soon. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. We have a small gale here north of Hawaii with producing 35 knot winds in conjunction with high pressure right behind it, making a bit of a gradient, so increasing the size of that fetch. Also looks like a front, though, is right here, likely to slam into the Hawaiian Islands. Some sort of a gale pushing off Kamchatka with 35 or 40 knot winds. Nothing of particular interest. And then look at this. As we get into Monday, a new little system just sort of pops up and starts riding to the northeast here pretty quick with 45, 50 knot winds. We'll see if it gets any traction. Oh, there we go. Pushing hard to the northeast. A broader system starts developing over Japan, though, on Tuesday morning with 55 knot winds. This one's probably the one more to watch. And it continues off. Look at this. 55, 60 knot winds as we get into Tuesday night. 60 knot winds as we get into, we'll say, Wednesday. Falling southeast, aimed well at the Hawaiian Islands and the U.S. West Coast, but a long ways away. Some swell likely to result from this if it materializes. Makes it to about the date line. We know the jet starts splitting there. Suspect that this one will just disappear and vaporize, and that's exactly what it does as we get into Friday. Notice this fetch of north winds here, low pressure. That's the backdoor front we were talking about. And then another little system develops off the Kuril Islands on Friday night into Saturday with 50, 45, we'll say even 55 knot winds, but we think it is going to make zero eastward progress, and that appears to be the case, maybe to the north dateline region. Another system showing up on Sunday, lifting pretty quick to the north. We know the jet stream's really split here, so there you go. It looks like it's all south winds in it as we get 180 hours out. Big high pressure, look at that, a 1040 millibar high, bulletproof high pressure, setting up, filling the Gulf of Alaska. So what that would do, circulation is clockwise around this, so there's your trades for Hawaii, really strong. You get the storm track ridging over this, and then down, pretty much down the coast. Not great for making anything but other than wind swell, but maybe bringing a hope of precipitation to the U.S. West Coast. All right, wave models. We're going back in time because we want to look at Storm 10 real quick. That's not this one. This was Storm 9. Swell from that has already hit California, and actually it was still lingering as of Sunday. Today there were waves maybe 3 or 4 feet overhead at top spots in Northern California today. Probably much less down into Southern California. But it was this system that has produced a very solid swell. On Wednesday, Thursday, seas were 52 feet, building to 55 feet, building to almost 56 feet. And then continuing as we go into Friday, fading from 55 feet to 51 feet Friday morning, continuing east from there, fading out from 43 feet, and by Saturday, it was done. You see the leading edge of the swell. This is the extra large swell that hit Hawaii yesterday. Large waves were indeed experienced. It was pretty much Waimea Bay, outer reefs, or Jaws, and that was it. Large, very raw at Jaws, but the outer reefs on the north shore of Oahu looked like they fared pretty well. That swell is in the water, pushing towards California for tomorrow. All right, so anyway, remnants of that system faded off, Storm 10. Also, actually, let's go back and take one little look. There was this other gale here that pushed off the Kuril Islands on Friday, falling southeast. Seas were, 33 to 35 feet. Nothing particularly noteworthy, but swell from that is pushing towards the Hawaiian Islands. Winds might be a bit of an issue. Some energy from that also might radiate towards the U.S. West Coast, but size-wise, nothing like what we've been seeing for quite a while. All right, let's go to the forecast now. All right, looking forward. Here we are, Sunday afternoon. Things Not particularly impressive. We know there's that little gale forecast there. This gale here with, what is that, 38-foot seas, all aimed off to the north. This little guy pretty much going to go do the same thing. No real swell likely to result. It's this system on Tuesday afternoon that we're most interested in, forming off the Kuril Islands, generating 45-foot seas right there. These are the highest seas over this whole domain, over the whole image here. Nice little bit of trickery and coding we were able to do to make that happen. Seas forecast to 52 feet on Wednesday morning. Building to 54 feet. So, again, good amount of wind, good amount of long period swell, but further away from Hawaii and much further away from the U.S. West Coast. So long period swell could result, but likely long waits between sets. Less so for Hawaii, definitely more so for California, and that's probably better part of 4 days out, something like that. Anyway, it continues. Whoops, where we go? What'd we get there? 49-foot seas and fading, making it to the date line right there on Thursday and pretty much vaporizing, and that's it. That is the new pattern that we're into. Saturday, little tiny thing forms up off Kamchatka. Yes, it gets, if they say, the model says 45-foot seas. We'll be lucky to see that. And very far away, limited to the far northwest Pacific. One more system forecast, pushing towards the date line, never really organized, and we don't expect much from that. So you can see a markedly different storm pattern from what we've had the pleasure of experiencing for the past month. If you're a big wave surfer, even small waves, if you can get in the right nooks and crannies, there has been surf, but it has been a bit overpowering at times, but we're not complaining. That's better than flatness. All right, a quick look at wind conditions. So here we are, Sunday afternoon. Yes, there's, we'll call it light north winds in Northern California right about this time, 5-10 knots. That's about what the model suggests. Notice winds turning from the south for Hawaii. Looks like that front setting up right there. We'll see how that plays out. Go into Monday morning, and you can see there's the front, north winds, 20 knots, pushing, looks like it into Oahu. First thing, 12Z, that's what? That's 2 a.m. Hawaii time. Okay, so we'll take it to 18Z. There you go, 8 a.m. North winds, okay, 25 knots for Kauai and Oahu. A forecasted strong northeast wind event for California as we get into Monday. You can see it. The wind barbs look almost due north out over open waters, but near shore, the high-res models are suggesting, at least in the morning, pretty strong northeast winds or north-northeast winds. You can see it better there as we get into Tuesday morning. The same thing, maybe even stronger, full-on north wind event, Kona wind event for the Hawaiian Islands. Nothing particularly good to result from that. Notice this low pressure building with high pressure up here. Very strong, 30 knot north-northeast winds for Tuesday morning over outer waters. And then a mellower regime starts setting up, but still offshore as we get into Wednesday. Winds trying to move to trades, but still northeast for the Hawaiian Islands. Get into Thursday, a light, let's just call it a light flow for California, kind of normal. Trades return to the Hawaiian Islands, 15 knots. Little like cut-off low pressure system forecast off of the U.S. West Coast, and high pressure starting to build, 1034 millibars here. This is the leading edge of what we think is a significant pattern change for California as we get into Friday. Low pressure moving into the coast, high pressure back behind at 1034 millibars, north winds building, trades for the Hawaiian Islands. So we get into Saturday, full-on north winds, 25 knot event, at least in North California. Central California will say 15 knots. Trades for the Hawaiian Islands, and this high pressure but just holding, fully locking down the Gulf of Alaska as we get into Saturday. And then Sunday, same deal. Here's the second lobe of that high building at 1040 millibars. We know the jet is doing this number way up like this and down like that, and then split down here. You can see it pretty clearly, split jet stream. If you're in the split or east of the split, always brings in high pressure. Here we are 180 hours out, Sunday night. Massive. I mean, that's 30 to 35 knot. That's wind swell or 12, 13 second period swell, but probably going to be very raw for California. Strong trades for the Hawaiian Islands. And this is the new normal we expect for a while. A quick look at precipitation potential. We're mainly looking at California here, Pacific Northwest. Snow. You see high pressure in control right now, this big ridge. The storm track has been coming in from the west, hitting the high, moving off to the north. We'll see what happens with this high as we get into, there's really no significant precipitation except up in, maybe British Columbia, something like that. Where are we? We're into Thursday. Then first little low comes off the coast Thursday night into Friday, providing some opportunity for light rain, maybe some snow for the Sierra. Building some, as this is much stronger than actually what was forecast yesterday. So that's good news. Rain, snow for the Sierra as we get into Saturday morning. Continuing falling south. The new double barrel high starts building on Saturday into Sunday. We're probably there. There's your model for Sunday night, Monday. Another backdoor front pushing down the coast. This one, we assume, will move over California as well. There's your 1042 millibar high. So with the high, instead of being here, sliding out to here, that allows the storm track to go up and over and then fall down the coast. Not great for surf, but hey, maybe it's time for snow. We'll take it. So yesterday at this time, we were working on the forecasts, and you know what the snow accumulation amount for Squaw Valley was? 2 inches. And then what a difference 24-hour makes. Now we're talking supposedly in the 42-inch range, something like that. Now, we think this is probably grossly overhyped, but still, it just goes to show you what a little change in the model, a little change in the pattern can do. I mean, this is actually, we need it. We'll take it. Yeah, I know the surf isn't great, but hey, we could go skiing. We need water for the summer. Not a bad call. And here is the temperature regime. Now today, what was it? Probably 72 degrees in Northern California, and gosh knows how warm it was in Southern California. Freezing level at Squaw was 12,000 feet. Supposed to dip down a little bit on the 19th, only then to go way higher, up above 14,000 feet. But notice, as we get into January 21st and beyond, a steady downward trend. And notice that syncs up with the blues here are the actual snowfall amounts. The reds are the accumulation. And so this is the base of Squaw. This is the top of Squaw. So falling temperatures, increasing precipitation, you get snow. And when you have snow levels down at, like 3,000 feet, a little drop of snow expands a lot more than if your freezing level was at the base or even higher. Wind situation. Let's go take a look at that. Well, you see a bit of a wind burst here, 90 knot gusts possibly on the 19th. But then after that, not too bad. Ushering in probably the pattern change somewhere right around the 19th. So what's that? 2 days from now? So here it comes. A quick look at Kirkwood, just a little bit south of Squaw. About the same picture. We'll say 39 inches of snow. Their higher elevation, 8,000 foot base instead of 6,400. So once we get into the precipitation window, freezing levels, not an issue. And wind, not too bad. Let's take a quick look at Mammoth, too. Because Mammoth is so much further south, and because these storms are all coming in from the north to the south, a lot of the moisture gets wrung out. They hit Tahoe, even though Mammoth is much higher. Tahoe is the first significant elevation the storms hit. It pretty much rings them out there. Maybe 11.5 inches total, and that's on the optimistic side. See, much higher elevation, base elevation 8,000 feet, sum it up at 11, but the precipitation amounts just not where we'd want them to be. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation, if it even exists, and of course, La Nina, or the El Nino Southern Oscillation. All right, MJO discussion up first. We like to look at winds on the equator in the Pacific. This is the East Pacific here. This is the West Pacific. That's the equator right there. The date line, international date line right there. That's New Guinea there. And it's in the West Pacific that we're really interested in, right in here. We call this the Kelvin wave generation area. When the active phase of the, so what is the MJO? It's a periodic weather oscillation. There's two phases, active and inactive phase. The active phase might be on one side of the planet, the inactive phase effectively on the other side of the planet. It is the active phase, which is actually like a big ball of low pressure. It travels from west to east on the equator, so sort of contrary to what you might think, but going this direction. And when the active phase is over the West Pacific right here, what it can do is reverse the trade winds. It starts imparting energy to the jet stream, and a strong jet stream helps feed the storm track, helps produce storms, helps produce surf, and of course snow. All right, it takes about 4 weeks for the active phase to traverse the Pacific. After it does, at some point the inactive phase comes in behind it and does the exact opposite, kind of stomps on it, enhances trades, and then in turn sort of shuts down energy transport into the jet stream. All right, so what are we looking for? Well, we want to see westerly winds in this area. That would be the active phase of the MJO, because that's the phase that promotes storm production. So in the East Pacific, we're just looking at the arrows. We see generally pretty strong east winds. Same thing over the Central Pacific. In the Kelvin wave generation area, exceedingly strong east winds. But it's not the winds what they actually are, it's how they compare to this time of year, right? Okay, so anomalies, differences, or wind speeds as they are compared to what they normally are this time of year. Yeah, we have strong easterly winds in the East Pacific, but that's kind of normal this time of year. You see the arrows are almost non-existent. But when you get into the Kelvin wave generation area, yes, they're extremely strong in the West Pacific, and anomalies, yeah, they're strong there too. This suggests the inactive phase of the MJO at a minimum, and we all know, I mean, we're just going to let the cat out of the bag here. This is, if there is no MJO and winds are this strong, then that typically means La Nina. Here's the wind forecast for the whole planet for the next week, but only the east-west component of the wind. They call that 850 millibars zonal wind anomalies. All right, what are we looking at? Well, the date line right here runs right up the middle of the chart. So the West Pacific starts about 135 east, so right about there, and the date line is there. And then, so what you can see, and the Kelvin wave generation area ends about 170 west right there. Purples are easterly anomalies. Now, this is the really interesting part. You can see these extremely strong easterly anomalies set up over the Kelvin wave generation area about December 23rd. That coincides pretty good with the start of our mega storm machine pattern, and it continued and has continued and is going to continue into another 4 days to January 21st. And all of a sudden, it just sputters. And that coincides quite well with the complete demise of our storm pattern as well. So, as we've been saying, we are theorizing that, yes, this is all associated with La Nina, but we believe that the outflow, so also, let's try it this way. You see here, this is the Indian Ocean, westerly anomalies, the hallmark of La Nina. It's basically the westerly anomalies that normally are over the Pacific move into the Indian Ocean. It makes like a big chimney, the Walker circulation, and the outflow from the Walker circulation, which is likely centered over the Indian Ocean, has been venting out across the Pacific, even though we clearly are in a La Nina pattern, and the jet stream should have been a mess during this whole time, but it wasn't. And we think this is representative of the inflow to the Walker circulation, then the outflow pushed out in the upper atmosphere. This was down at the surface, effectively. And then the outflow fed the jet stream, which fed our storm track, which gave us all the storms that we've had, the swells for the past month. We think that with the collapse of the easterly winds, the jet stream is also going to collapse. That doesn't mean the Walker circulation is going to collapse, but they were in sync for a bit of time, and that played to our advantage. We had our window we think that window is collapsing. Anyway, all right, so for the next week, easterly anomalies collapsing, westerly anomalies somewhat holding here in the Indian Ocean. Westerly anomalies, so notice this, a building westerly wind anomaly pattern. California's, the coast is like at 120 west. That might help feed our precipitation potential right along the California coast. So more to follow on that. All right, let's go out 2 weeks. This is the statistic model. This is what this is showing. This is not winds. Another component of the MJO is precipitation, right? And we said that the active phase of the MJO acts like a big low pressure system that moves around the planet from west to east. All right, so here we are today, South America, Central America, Mexico there. Where are we? There's Australia, New Guinea there. Dateline right there, equator right there. The oranges are, this is outgoing long wave radiation, fancy words for sunlight reflectivity off the ocean surface. And if you have a lot of sunlight bouncing off the ocean surface, that means you don't have clouds. That means you don't have low pressure. High pressure, we'll call that the inactive phase of the MJO. And the active phase, the exact opposite, is over here in the West Pacific. As we get into 5 days out, more of the same, but notice this model, the statistic model, says by about a week out or so, active phase of the MJO moving into the West Pacific and over the Kelvin wave generation area. So that theoretically would be favorable for storm production in that it would impart energy to the jet stream. The dynamic model here suggesting, sort of the same thing, maybe the active phase, almost the same strength. So potentially an active phase, but after what we've had and what the pattern has been, and we suspect this active phase will not do a whole lot to promote storm production, but we're hoping that the atmosphere proves us wrong. The upper level model, it is the basic. We think this is a statistical model. You can see here, active phase of the, so the greens are areas favorable for precipitation. Orange is not favorable for precipitation. Loosely equated, this is the active phase of the MJO. This is the inactive phase. The equator is right there. There's South America, Central America, New Guinea. Dateline roughly right there. Kelvin wave generation area. This is the area where if the active phase is over here, it imparts energy to the jet stream. Looks like the active phase is to move over that area January 22nd through about the early part of February. Then the active phase moves across the Pacific and into Central America about late February, February 21st, something like that. When the active phase is south of California, so right in here, this might be a sweet spot for precipitation in California. So maybe the second week of February, something like that. Then right after that, strong inactive phase of the MJO sets up again, pushing across the Pacific starting, beginning of the second week of February, continuing on into the end of February. And then the CFS model, this goes out 1 month, basically saying the same thing. Here is here is the dateline right here. Okay, this is the whole plan on one chart. Kelvin wave generation area starts right about here, goes to right about here, 170 west. California's over here. All right, so you see we have this dotted purple line. That is the high pressure bias, the La Nina signature, and we had not only did we have La Nina with 2 contour lines, but we had the dotted black line, inactive phase of the MJO at the same time. These are basically 2 oscillations. They sync up together. They pump like mad. That's exactly what we had in the first week of January. Now here we are, the January 16th. East anomaly still in control for maybe a couple of days. And here is equatorial Rossby wave. There's the active phase of the MJO. We suspect it will slowly move across here, but so weak will have no influence whatsoever. Notice a little bit of westerly anomalies here in the Kelvin wave generation area. So we'll see as we get into the end of January, but no real obvious hope. The one thing that is interesting here is these the low pressure, the high pressure bias here, 2 contour lines, pretty broad and wide. It was even 3 contour lines here, down to 1 contour line as we get into late January, early February, and shrinking in coverage. So maybe the demise of La Nina is at hand. And then finally, the 3-month CFS model. It's different. Here is past performance. The forecast is up here. Date line running right up the middle of the chart. Kelvin wave generation area starting about here, going to about here. Now it's interesting. You see this big long patch of blues, easterly anomalies, the La Nina signature. It's supposed to hold strong according to this run of the model for about another couple of days. Then things kind of break apart. Tries to make another wake-up call somewhere in March, probably associated with the inactive phase of the MJO, but it looks like it's not as bulletproof as it has been. Let's overlay the MJO component here first, all right? So the dotted contours are the inactive phase of the MJO. So inactive phase of the MJO moving east, this direction, and out of the picture by, we'll say, January 25th. Here's the solid contour, active phase of the MJO. Now, it's not a strong one. We saw that on all the other models, so some active phase is coming. With limited westerly anomalies, not sure if that's really going to do a whole lot for storm promotion or production, but we'll sort of say, okay, maybe. We'll give it a maybe, and that pattern's to hold to some degree into about February 26th. Then a pretty broad and long inactive phase of the MJO sets up. Raging pretty good, apparently, in the March time frame. That's sort of the tail end of winter, right on the verge of spring. Not sure how much influence that will have, followed by the active phase of the MJO. All right, let's overlay the low-pass filter here real quick. All right, so we're going this direction. Right now we have 1, 2, 3, 4 contour lines. This is the high pressure bias over the Kelvin wave generation area. It lasts at 4 contour lines into about, right about the same time the MJO fades out. And then it's inactive phase of the MJO, high pressure bias. Maybe we'll get some jet stream support like we did this last pattern. I'm not really buying that completely, but maybe, just maybe. The other thing is, though, notice we go from 1, 2, 3, 4 contour lines down to 3. Tries to make a comeback, but not really. The coverage not looking maybe quite as strong. The low pressure bias right here is in the Indian Ocean. It peaks out right about, we're in the peak of it right now, fading in February, and then theoretically, we're hoping La Nina will die somewhat, but we suspect it's not gonna. So if it were gonna die like really quick, it would, and strongly and dramatically, and be replaced by an El Nino. It could happen as early as the February, March time frame, but we suspect this La Nina thing is going to hold on till September or October. The atmosphere will be predisposed, and the winds will be pushing, upper level winds will be pushing that direction. It'll take months for that to sort of return to a quote unquote normal state. That wouldn't happen. So maybe December or January, a year from now, maybe we'd be back in a normal pattern. And then we might be keeping our eyes open. We've talked about this before. Warm water buildup in the West Pacific, and with the demise of the trades and the demise of La Nina, could set us up for an El Nino, but it wouldn't be this year. It would be a year from now, and it really wouldn't even manifest till the fall of that year. So that'd be, what are we in, 2021? So it'd be the fall of 2022. So that's a year and a half from now. That's when we might move back into a really productive pattern. So let's be clear. This past month has been epic, okay? And it was totally unexpected and totally unsupported by any normal kind of view of the El Nino, La Nina type thing, it was a gift. I'm glad we had it. I'm not complaining at all. But the next window for the next gift might not be until a year and a half from now at the earliest. So, more to follow. All right, so let's go take a look at the La Nina situation. First, in the ocean, under the ocean, in the ocean at depth. So this is the East Pacific. West Pacific here, data from the TAO buoy array, series of buoys strung across the equator in the Pacific used for monitoring El Nino. See these little black X's? You can see them right there, there. These are the anchor lines on the buoys. The X's are the sensors. The sensors collect data, send it up to a central processing facility in the northeast U.S. They apply a model to it, and you get a profile of subsurface ocean temperatures. The 28-degree isotherm line at 170 east. It's actually backtracked from like 175 or so, or 173 last week. So warm water continuing to get pushed to the west. 24-degree isotherm is 24 degrees centigrade at about 115. I think that's about where it was last week. But you can see most of the warm water's all back here. None of it's sloshing east. No Kelvin waves, or at least nothing apparent. And a very shallow thermocline, warm water pattern in the far East Pacific. But again, it is anomalies, differences from normal for this time of year. You see a markedly cooler pattern, though not as bad as it was a couple of months ago. 2 degrees centigrade below normal here, and generally south of Hawaii, filling the entire eastern Pacific. Where's the date line? I think it's somewhere right around here. And even west of the date line, pretty much the entire equatorial Pacific is cooler than normal. Here is our warm anomalies at depth, 2 degrees centigrade, making it to about 165 west, so not even to Hawaii, and not nary a sign of it moving to the east, nary a sign of any winds that would be westerly anomalies here to try to drive that to the west in the form of a Kelvin wave. Nothing. So again, La Nina static pattern in control. Another view of that data, a little bit more detailed, showing temperatures warmer. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So a little ball of, let's say, 4 degrees centigrade anomalies here. And temperatures cooler than the other model, but not as cool as they've been. So these temperatures, the cool anomalies, are moderating in the East Pacific, while warm temperatures continue to build in the West Pacific. Trades continue to nuke. Just so what that does, that creates upwelling. That also prevents warm water from trying to track. You have no real effective active phase of the MJO in the West Pacific here. No westerly anomalies, nothing to push this warm water. So it just sits here and starts building and building and building. And as long as the trades keep nuking stronger than normal, they will stay locked there. But at some point, and we're not sure when that point's going to be. It could be as early as February, highly unlikely. More likely February a year from now. The winds will break, and all of a sudden you'll see a massive flood to the east of warm temperatures. The active phase of the MJO will wake up, and that would usher in El Nino. But we think we have another year of La Nina for now. Sea level anomalies, really no change here. This is, there's Chile here, Peru here, Central America, Mexico, the equator right there, date line there, New Guinea right there. So this is not temperatures, though it looks very much like it's the height of the ocean surface. You take the Jason 3 satellite, some other satellites, they measure the height of the ocean. If you strip away the waves, the wind waves, the tides, the Earth is a sphere. And if there's a small deviation in the spherical surface, the satellite can sense it. We're talking 5 centimeters here, 10 centimeters here, 15 centimeters here. Okay, why is that? Well, we know for a fact we got easterly trades blowing, pushing water this direction, and we know we have cold water at depth. Cold water contracts. As it contracts, it creates a little divot on the ocean surface. Between that and the east trades scooping everything out and pushing water this way, you see you have a big buildup here of 20 centimeters, what is that, maybe 25 centimeters above normal. So you get so there's just another way to sort of verify temperatures. Warm water here, cold water here, but we're using height to do it. Just indicating the La Nina pattern. Still, it's like a dagger. This big triangle, cold water here. Just like El Nino, if it was El Nino, it'd be a big triangle of warm water here and the cold water over here. So the exact opposite. Okay, and this is just confirming what we've seen in the other charts. This is the chart that gives us encouragement. It's just a sort of a historical look from February a year ago to today. East Pacific here, West Pacific here. The blues are colder than normal temperatures. This is at the beginning of our La Nina in, we'll call it mid-April, something like that, of 2020. Cold water backed off for a little bit. Very cold. Probably the peak of La Nina right around Halloween. Now, you see cold water continuing. It's actually moving. Instead of being focused back here, it's actually moving to the west as the trades continue to nuke, push it forward. Notice the warm temperatures building over in the far West Pacific. Pretty warm there. What is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 degrees above normal. And this is a degree or a degree and a half. And this is not at the surface. This is, down up to 300 meters. So gives you a sense of the balance of heat at depth in the Pacific Ocean, suggesting strong La Nina in play. Warm water buildup here, that gives us hope for the future. The question is when. A quick look at sea surface temperature anomalies, okay? Differences from normal for this time of year. Kind of a fractured pattern, but these are all high-res images. There is Chile here, Peru here. You see cold water streaming off of Chile and Peru. The equator's right here. Notice there's little pockets of warm water starting to show up, just like there were some little pockets right here. And notice this right in here. This was much, much colder a month ago, 2 months ago. Warming up, bordering on almost neutral, though there is this well-built flow running here, and then pretty cold off here in the central to west Pacific. Where is that? That is 140 west, so Hawaii's, there's Hawaii right there, so you get the idea. South of Hawaii. So the indication here is trades are blowing here, maybe not as hard as they were in the East Pacific, but strong from Hawaii on west. That would be high pressure here driving those trades, right? Okay, and then high pressure down here rotating in the opposite direction. The convergence of the two high pressures is where you get this just stronger than normal easterly winds blowing into the West Pacific, causing upwelling, dragging all the cold water across the Pacific and building basically a wall in the West Pacific. All right, sea surface temperature trend, just the past 7 days. We see generalized light warming just south of the equator, a couple little pockets of cooling, but in large, the balance here is warming, and it's really 5 degrees north and south of the equator that we're most interested in, so the warming right here, and otherwise a pretty neutral static pattern out here to the west. And then the backed off view, very much like what we saw before. Temperature's not nearly as cold here south of the Galapagos in this little region here. Still pretty cold off of Chile, suggesting easterly winds here. We assume the high pressure is here. This warming right here is probably right at the center of the high where there's no wind at all. So the sun just cooks. There's no clouds and the water temperature's warm. But high pressure there. And then the same deal here. Probably the center of the high somewhere right around in here, generating also easterly trades, and then you get your upwelling pattern right here, and then all your warm water at depth is sitting right around in here, all in this area, and this is what we would expect to be unleashed sometime, who knows when, in the next year, let's say. Sea surface temperature values in the Nino 1.2 region. This is the area right there around Chile and Peru where we said there is some warming. You can kind of see the upward trend. Today's value, half a degree, 0.638 below normal. Right there, down a little bit the past 2 or 3, 4 days. But still, pretty warm. Boy, this is not the official El Nino monitoring region, but El Nino is a half a degree below normal for 5 consecutive months. In this region, we have been there for sure. We're almost hinting at trying to return to normal, but a 7 or, a week? We'll give it 8 days does not make a trend, but it's a baby step in the right direction. It is the Nino 3.4 region right here. The official El Nino monitoring region from 120 west, that's south of California on the equator, almost out to the dateline, 5 degrees north and south of the equator. Today's value, 1 degree below normal, minus 1.058. And you can see here, it is, yeah, we were colder, but right now, very stable, not going anywhere. We do not expect the immediate demise of La Nina at all. We are in a very stable position right now. I think the atmosphere and the ocean are in sync with one another. They are what they say, quote unquote, coupled. They're acting in unison, and this will probably not dissipate until we get, at least some sort of change in the seasons, and maybe that'll help nudge us. In fact, we are, when we move into spring, I don't remember exactly. I think it's somewhere in the March time frame. You get into what they call the spring unpredictability barrier. That's talking about, well, are we moving to La Nina, El Nino? What, where are we going to go? And that runs from like mid-March out into late May, maybe early June, something like that. The models have a real hard time knowing what's going on during that period. The seasons are changing. There's a lot of interesting dynamic things that are happening in the atmosphere, and it gives the models a hard time to try to make a accurate prediction of where we're going to be. All right, let's move on. All right, so we talked about the MJO. We talked about the subsurface component of La Nina. We talked about the ocean surface temperature component of La Nina. Now we need to talk about the atmosphere, because we said they're coupled, right? What the ocean is doing is what the atmosphere is doing. Let's see if we can prove that thesis. All right, so Southern Oscillation Index, difference in pressure between Darwin, Australia, which is almost in the Indian Ocean, and Tahiti, which clearly is in the Pacific. When the daily index is negative, that suggests lower pressure in the Pacific. When it's positive, higher pressure in the Pacific. We've been talking here about these easterly anomalies, easterly trade stronger than normal, being driven by high pressure. So it's no surprise to see today's value at 20.69, meaning strong high pressure in the Pacific. And you just sort of scan down. We're not even going to scroll. You get the idea. It's been positive forever. The 30-day average takes 30 days worth of these values, averages them together today. Strongly positive, 18.39. Clearly at a bare minimum, a strong inactive phase of the MJO. The 90-day average takes 90 days of this data, average it together today, 12.45. We were saying the La Nina is about when you hit 12, something like that. Well, we're there now. Clearly, we're in La Nina. Clearly, we have been in La Nina for a long time. This is a lagging indicator, but what it suggests is that the atmosphere, the ocean are in sync. They're all saying La Nina. They're working together to reinforce and keep La Nina in play. This is a big boat. The atmosphere and the ocean are both working together now. They're not going to be dislodged easily. It's going to take some time. And even if it does, if let's say the ocean somehow changes or the atmosphere somehow changes, before they get in sync in some other pattern, it's going to take months, half a year or more. So right now, clearly in La Nina mode as much as one can get. And finally, the sea surface temperature forecast from the CFS model. All right. And this is in the official El Nino monitoring region, sea surface temperatures in the Nino 3.4 region. All right, so where are we? This line here is mid-January. We're a little bit past that. Temperatures, according to this, are about 0.765 of a degree below normal, but I thought we just looked on another chart and we're right at 1 degree below normal. So this is actually being quite generous. Anyway, the forecast suggests slow warming into April to maybe 0.4 of a degree below normal, and then just sitting there steady as we get into next fall. We looked at a consensus model of all the different models. They say, oh no, moving right to neutral. I think that is highly unlikely given the depth of the coolness in the ocean in the East Pacific, the coupling of the atmosphere in the ocean, just all the signs suggest this pattern is not going to be dislodged anytime soon. But we suspect that when it is dislodged, it will dislodge in a fairly dramatic fashion. It just won't limp back to normal. There is a lot of latent heat energy in the oceans. We haven't had a good El Nino for a while. Our number is going to come due at some point. We don't think it's going to be this year. We think it will be maybe the year after that at the earliest, but more to follow. All right, well, so for the immediate time being, there is swell in the water. Swell from storm number 10 that hit Hawaii yesterday is on its way to California. And then there's another storm forecast off of Japan after that, with pretty decent seas, pretty good distance away from both Hawaii and California, and maybe some smaller things after that, but clearly a downward trend in the surf pattern as compared to where we were a week ago. Mavericks was 60 feet, something like that, and classy. You can't really go upward from there, so downward is maybe not that bad of a thing. But the jet stream supposed to unzip, become very split. We suspect we're going to go back into the mode where at some point you better just get any surf you can. Right now, it's not bad. It's like our arms need a break. We'll take a little break, recuperate, but then we're going to start getting desperate for surf again. We suspect maybe give it a week or 2 weeks out, something like that. So get what you can, make the most of it. The good news is we think some precipitation is on the way for California, maybe some snow for the Tahoe region. That's looking good. And then we'll just see how it plays out. Long term, yeah, we're still definitely in the La Nina mode, and I think that's going to continue for quite a while. We can keep our eyeballs out for the coming of El Nino, but I think that's going to be a pretty long-term outlook, and certainly at best highly speculative at this early point in time. All right, so if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you have comments, please post them to the site, and we will reply. We think we'll be a bit more available now that the surf is going to be dropping off. And then if you haven't subscribed, please subscribe. You get automatic notifications of when we post the videos. If not, just go to stormsurf.com. All the data you've seen tonight is available there. You can follow along, plus buoys and all kinds of stuff, so you can fully geek out and enjoy it. If you have questions, again, post them to the YouTube site and we will answer them. All right, thank you for watching. It's always fun doing this, and we'll do it again next week, same time, same channel. See you then.